Welcome to The Explainer. Today, we're going to take a whirlwind tour of our own cosmic neighborhood. We're going to journey from the blazing heart of our system, the sun, all the way out to its most distant, icy frontiers, to really get a feel for the worlds that share our home. But before we start meeting all the planets, let's hit rewind and go way, way back to the very beginning. So, how does a solar system like ours even get started? Well, it all kicks off billions of years ago with this enormous, cold cloud of just gas and dust floating around. Then, gravity, as it always does, starts to work its magic, pulling everything together. The cloud collapses and begins to spin, flattening into a disk. Right at the super dense center, the pressure and heat get so intense that, poof, a star ignites. That's our sun. And all the leftover stuff swirling around in that disk, it starts clumping together, forming the planets we know and love today. Okay, so now let's journey right to the heart of the system, to the star that holds it all together and, let's be honest, powers pretty much everything, including life itself, our sun. We tend to think of the sun as just a big, simple ball of fire. But if you could peek inside, you'd see it's this incredibly complex, layered nuclear furnace. The energy starts in a core that's a mind-boggling 15 million Kelvin. That's over 250 times hotter than its own surface. From there, it has to travel out through these different zones before it finally bursts out into space. And just to really hammer home how dominant the sun is, get this. It is so unbelievably massive that it contains 99.9% of all the matter in our entire solar system. Everything else, every single planet, moon, and asteroid combined, is just crammed into that leftover 0.1%. All right, let's move a little closer to home, into the inner solar system, and see how our world really stacks up against its closest and, as you'll see, very different rocky neighbors. This comparison table right here perfectly illustrates the whole Goldilocks effect. On one side, you've got Venus, whose super thick carbon dioxide atmosphere has created this runaway greenhouse effect, making it hot enough to literally melt lead. Then on the other side, you've got Mars, whose atmosphere is so thin it's just a frozen desert. And right there, smack in the middle, is Earth, just right. It's a pretty stark reminder of how fragile and special our life-sustaining conditions really are. And each of these inner worlds has its own wild story. Mercury, for example, is way denser than you'd expect because it has this massive iron core. Venus is just a total hellscape, scorched by these planet-wide high-speed winds. Our own moon, probably born from a completely cataclysmic collision between an early Earth and something the size of Mars. And Mars itself shows us signs of a really dynamic past, with those famous polar ice caps and ancient volcanoes. Okay, time to head to the outer solar system. We're going to cross the asteroid belt, which is basically a bunch of rubble that Jupiter's immense gravity kept from ever pulling itself together into a planet, and now we enter the realm of the giants. And speaking of Jupiter, here's a fun fact for you. It's basically a failed star. Seriously. It's made of the same stuff as the sun, hydrogen and helium, but it just didn't get quite big enough to kickstart nuclear fusion and become what's called a brown dwarf. So while it's definitely the king of the planets, it's also kind of a cosmic wannabe. This whole region out here is just vast and incredibly diverse. First, you hit the massive gas giants, Jupiter and Saturn. Then you get to the colder, kind of mysterious blue ice giants, Uranus and Neptune. And then, way, way out beyond all of them, you find the Kuiper Belt, this distant frigid zone full of icy bodies. It's where comets are born, and it's home to a whole bunch of dwarf planets. And speaking of dwarf planets, well, that brings us to a famously controversial question, one that not too long ago forced us to completely rewrite our maps of the solar system. Ah, yes, the great Pluto debate. Its demotion back in 2006 sparked a huge public outcry. And honestly, a lot of people are still a little sad about it. But the reason it was reclassified wasn't emotional at all. It all comes down to a clear, scientific definition that was set by the International Astronomical Union. So here's the deal. The official definition has 3 rules, and a celestial body has to check all 3 boxes, no exceptions. 1, it has to orbit the sun. 2, it's got to be big enough for its own gravity to pull it into a round shape. And 3, it has to have become the gravitational bully of its own orbit. And this is where Pluto gets tripped up. It orbits the sun? Check. It's round? Check. But that third and final rule, it fails. Big time. Its orbit is right in the middle of the Kuiper Belt, a super crowded area with thousands of other icy objects. It hasn't cleared its neighborhood at all. It's really just one resident among many. And that, right there, is why it was reclassified as a dwarf planet. So our tour is ending here for today. But this whole debate about Pluto is a great reminder that our understanding of the universe is always changing, always evolving. It really leaves us with one last kind of inspiring thought. With every new telescope we build and every probe we launch, we're pushing the boundaries of what we know. What other incredible secrets and surprises are still out there, just waiting for us to find them in the vastness of our own solar system and beyond?